Now we're going to solve nonlinear inequalities, which means we're going to have to graph things that are not straight lines. So here are a couple for us to try. Again, it's important for us to understand what the shape should look like. So looking at this first one, hopefully we all recognize this as a circle. We've talked about how to graph a circle. It's actually pretty straightforward. To graph a circle, you find the center, which is h comma k. And in this case, that would be 3 comma, this would be y minus -2. So 3 comma -2 would be the center of my circle, 3, -2. The radius here would be the square root of 9, which is 3. So I would go 1, 2, 3, 1, 2, 3, 1, 2, 3, and 1, 2, 3. That's my circle. Now from here, I do the same thing as before. Is it a solid line or dashed? Obviously this is dashed. When choosing a test point, I choose a point that is either inside the circle or clearly outside the circle. I'm going to choose 0, 0 because I'm fairly predictable in that way, and I want to do the easiest math possible. So 0 minus 3 is -3, squared is 9. 0 plus 2 is 2, squared is 4. So I get 9 plus 4 is less than 9, or 13 is less than 9. True or false? Obviously 13 is not less than 9, so 0, 0 shouldn't be shaded. So now that means I should have shaded the inside of my circle. The second one is a parabola. Hopefully we can all see that because there's an x to the second, but y is to the first power. So I want to graph as I would if it was y equals x squared minus 3x plus 4. A couple of easy things to do when you're graphing. First is obviously to find the vertex. That's the most important point. So the vertex, remember, is the opposite of b over 2a, and then actually plugging in the opposite of b over 2a to find the y value. This one's going to be a fraction, but it shouldn't matter. If I find the opposite of b, so positive 3 over 2 times 1, that is the x value of the vertex, 3, 2. So the opposite of b, so b is -3, the opposite of that is positive 3 over 2 times 1, so 3 halves. I'm going to now plug in 3 halves. So y is equal to 3 halves squared minus 3 times 3 halves plus 4. Yes, it's going to be a fraction, but that's okay. 3 halves squared is 9 over 4. -3 times 3 halves is -9 halves plus 4. Let's reduce that a little bit more. If this is 9/4, let's call this 18/4. So now I have -9/4 plus 4. And if you want to call that 16/4, that might be easier. So -9 plus 16 gives me 7. So 7/4. That is my vertex. So 3 halves, which would be like 1.5, comma 7/4, which is not quite 2, so somewhere in here is the vertex. Now, why do I care so much about the vertex? Because that's where my axis of symmetry is, which cuts my workload directly in half, because any value that I find on the left side, I can reflect it to the right side or vice versa. So the vertex is one thing I definitely want to graph. The other is using that c value, because the c value is the y-intercept. So at positive 4, it's going to go through the y-axis. Now notice that's 1.5 units away, so 1.5 units away to the other side right here. If I want to, then I can find another point. So say plug in 4 and see what happens. So if I get 4, that would be 4 squared minus 3 times 4 plus 4. 4 squared is 16. Minus 12 plus 4 would give me 8. So at 4, it goes through at 8. That's 2.5 units away, so 2.5 units away on the other side would be negative 1/8. And now, again, this is going to be a solid line because of the or equal to. And then I choose a test point. I'm going to choose 0, 0 again because, hey, why not? It's the easiest math there is. So then 0 squared is 0, minus 3 times 0, which is 0, plus 4. I'm saying, is 0 greater than or equal to 0 minus 0 plus 4? So is 0 greater than or equal to 4? Not the last time I checked. This is false. So don't shade towards 0, 0. Shade the opposite side. Here are 2 questions for you to try, so try them both and then press play to check your work. Remember, if you get confused as to how to graph something, it's always okay for you to plug in a value for x and find out what y is, or vice versa. So for the first one, this is a square root function, and if you'll remember correctly, a square root function, the parent function goes through at 0, 0, and looks something like that. So it's sort of like a parabola, half of a parabola turned on its side. Now, when we're graphing this one, however, we need to keep in mind that obviously a transformation has occurred. This plus 3 doesn't move it 3 to the right, but moves it actually 3 to the left. If you're not sure about that, remember, we know a square root function, the square root has to be greater than or equal to 0. So if I solved this, I would find that x has to be greater than or equal to negative 3. I'm sorry. Yes, that's fine. Greater than or equal to negative 3. Now, in terms of this, though, this is not an or equal to. So when I'm plotting that point, I'm actually going to plot an open circle rather than a closed circle. I probably should have done that on the parabola I graphed also, but that's okay. Now from here, I just need to find a couple of other points. So obviously I'm going to try to find some points that are nice. So for instance, if I plug in negative 2, negative 2 plus 3 gives me y is less than the square root of 1, which is 1. So if I plugged in negative 2, I got 1 back out. And I wouldn't want to plug in negative 1 because negative 1 plus 3 is 2, and the square root of 2 is fraction, or excuse me, decimal, which I don't love. So I might plug in, say, 1, because if I plug in 1, I get 1 plus 3, which is 4. So y is greater or less than the square root of 1 plus 3, so y is less than 2. So that 1 comma 2 is a point. So I would probably stick with that. And then from here, I then have to use a test point. So should I use 0, 0? I don't see why not. Plug in 0, 0 because it's not a point on my line. I get 0 is less than the square root of 0 plus 3. Is 0 less than the square root of 3? No, it's not. The square root of 3 obviously is greater than 0, which means 0, 0 should not be shaded. So we're going to draw a little dotted line down here, and it's going to be pretty much everything else that should be shaded. That's how you would shade that one. The other one, again, this one is going to be a circle. We know it's a circle because it's a 1 in front of the x squared and a 1 in front of the y plus 1 squared. The center of this circle is hk, which is 0 because we haven't added or subtracted anything from x, comma negative 1 because this would be y minus negative 1. So 0, negative 1. The radius is, of course, 4. So 1, 2, 3, 4 in all directions. This one would be a solid circle. Do your best to make it look like a circle. And then, of course, choose a point, plug it in. I'm going to choose 0, 0 again because why not? I get 0 squared plus 0 plus 1 squared is greater than or equal to 16. And that is clearly false. It is not. This would be 1 is greater than or equal to 16, which is not true. If it's not true, don't shade it. Shade everything else. So everything on the outside of that circle should be shaded in, and the circle itself should not.